For 2 years, we've operated under a single assumption that the only limit to the AI revolution was the speed of our code or the depth of our pockets. But today, the global tech stack has hit a very hard, very physical wall. And it's not because we ran out of money. It's because we're running out of helium. Right now in the Gulf, 30% of the world's supply has vanished following the strikes on Qatar's Ras Laffan. That is 5 million cubic meters of gas taken off the market every single month. Now you might be asking, what does a gas used for party balloons have to do with my GPU or a neural network? To make the chips that power AI, we use a process called EUV lithography. These machines are the most complex tools ever built, and they run incredibly hot. Helium is the only element in the universe that can cool the wafer backside during this process without reacting with the silicon. It has the highest thermal conductivity of any gas we can use at scale. If you don't have ultra-pure 6N grade helium, the silicon warps at a subatomic level. Without it, a $20,000 wafer becomes high-tech scrap metal. But it doesn't stop at the factory. Quantum computing. The systems promised to break our current encryption and solve drug discovery require temperatures near absolute zero. Liquid helium is the only fluid on Earth that stays liquid at those temperatures to keep qubits stable. Data centers, even your high-density AI server racks pushing 100 kilowatt per rack, are moving toward helium-sealed drives and specialized cooling loops because air simply can't handle the friction and heat anymore. The MRI crisis. This is where it hits home. Every standard MRI machine in our hospitals relies on a bath of about 1,500 to 2,000 liters of liquid helium to keep its superconducting magnets at 4 Kelvin. Without that cooling, the magnet quenches. It shuts down, and the machine is essentially a multi-crore paperweight. We built $1 trillion digital empire on the back of a gas that we can't manufacture. And that, as of this month, the world is losing at an alarming rate. The common misconception is that because helium is the second most abundant element in the universe, it should be easily accessible. But on Earth, the physics are much harsher. Atmospheric helium is so dilute at just 5 parts per million that extracting it from the air is thermodynamically and economically unviable. We're entirely dependent on terrestrial traps, helium that has been produced by the radioactive decay of uranium over millions of years, captured deep within specific natural gas deposits. Once it's released into the atmosphere during gas extraction, if we don't capture it immediately, it is lost to space forever. It is in every sense a non-renewable planetary asset. This geological rarity has created a global supply chain that is dangerously consolidated. As of March 2026, over 80% of the world's refined helium comes from just 3 primary hubs. The United States, contributing to 43%, predominantly from the ExxonMobil facility in Wyoming and the Federal Helium Reserve. Qatar, contributing to 33%, centered at the Ras Laffan industrial city, the single most critical node in the global supply chain until the strikes earlier this month. And Russia and Algeria, approximately 12%. While Russia's Amur plant was designed to be a global stabilizer, sanctions and technical glitches have kept that supply line erratic at best. When Ras Laffan went offline on March 2nd, the tech industry didn't just lose a supplier. It lost 1/3 of the planet's commercial volume in a single afternoon. Unlike crude oil, there are no strategic helium reserves large enough to bridge a multi-month outage. We're looking at a just-in-time supply chain that has no margin for error. But why is the tech world panicking now specifically? It's because of the move to 2 nanometer and sub-2 nanometer nodes. As we shrink transistors to near atomic scales, we move from standard lithography to extreme ultraviolet EUV lithography. These machines made by ASML are the only way to print 2 nanometer logic. But here's the catch. EUV light is so sensitive that it is absorbed by literally everything, including air. The entire process has to happen in a high vacuum. You can't just use balloon-grade helium. Fabs require 6N grade. That's 99.9999% purity. Even 1 part per million of moisture or CO2 can fog the EUV mirrors. And guess which plant was the world's primary source for high-volume 6N helium? Ras Laffan in Qatar. For decades, hospitals were the biggest helium users. But as of this year, semiconductor manufacturing has officially overtaken healthcare as the world's largest consumer. High-end chip making now accounts for over 20% of global demand. With 42 new mega fabs scheduled to come online globally by the end of this year, including our own projects in India, we're building a massive engine. but running out of the only lubricant that makes it work. As the realization sets in that helium is a strategic choke point, we're seeing a massive coordinated pivot. The world's leading tech economics are moving from a just-in-time to a circular model. South Korea is currently the most exposed, sourcing nearly 65% of its helium from Qatar. To survive this month's blackout, Samsung has accelerated the deployment of its helium recycling system, HERS. Developed with local partners, this system is now operational on their most advanced lines, recovering and purifying exhaust gas to a reuse rate of about 19%. It's the difference between a total shutdown and maintaining baseline operations. In Taiwan, where TSMC produces the world's AI brains, the strategy is extreme diversification. While they've maintained a 6-month buffer, they're now aggressive in closed-loop recovery. In Taiwanese fabs, helium is treated with the same reverence as water. Over 70% of their advanced facilities now feature some form of reclaimed infrastructure, a stark contrast to the global average. The US is in the middle of a controversial transition. Having recently completed the privatization of the Federal Helium Reserve, the focus has shifted to primary helium mining. Companies like Pulsar Helium are now flow testing massive discoveries in Minnesota, drilling for helium as the main target, not just a byproduct of gas. These are standalone helium wells that could decouple the tech industry from the volatile natural gas market forever. But we have to be realistic. Innovation isn't an instant fix. Even a 20% recovery rate leaves an 80% dependency on newly extracted helium. In an era of exponential AI growth, recycling alone can't bridge a 30% global deficit. And those helium-first wells in the US are the future, but they won't hit commercial scale until 2027 or 28. They don't solve the crisis we're facing today. And most importantly, helium is the ultimate escape artist. It leaks through solid steel. You can't just stockpile your way out of a multi-year shortage. So the world is in a desperate race to engineer its way out of this bottleneck. But for a rising power like India, sitting at the very end of the global supply chain, the pressure is immediate. Today, we are 100% import dependent. Right now, India consumes roughly 10 million cubic meters of helium every year. We don't produce a single commercial drop of it. While the helium is born in the gas fields of Qatar or Russia, the way it reaches India is through a complex logistical web. Over 35% of our supply is actually transshipped through the UAE. Most of the Qatari liquid helium is moved to hubs like Jebel Ali before being redirected to Indian ports like Hawa Sheva. Roughly 30% comes directly from Ras Laffan, making us hypersensitive to any disruption in the Persian Gulf. In the last year, we've seen a significant uptick in imports from Russia's Amur facility. It's been a necessary pressure valve, but it's a supply line constantly shadowed by geopolitical sanctions. But as of this week, the crisis hitting our shores isn't just about the gas. It's about the logistics of war. With the recent strikes in the Gulf, shipping giants like Hapag-Lloyd and MSC have triggered force majeure and implemented a war risk surcharge. Because our supply must transit the Strait of Hormuz, Indian importers are now facing an additional $3,000 to $4,000 per container. This shock is a wake-up call for the India Semiconductor Mission 2.0. In the February budget, the government provided a specific 1,000 crore outlay for this fiscal year to move beyond just building fabs. The goal now is to secure the entire substack, the equipment and the high-purity materials like helium. On the bright side, the Engineers India Limited and ONGC greenlit the nation's first helium recovery demonstration plant in Kuttalam, Tamil Nadu. Using indigenous technology, the plant aims to recover 99.995% pure helium directly from our own natural gas streams. While Kuttalam is currently in the demonstration phase, it represents a critical pivot toward Atmanirbhar energy. If we want to survive the helium crisis of 2026, we have to treat helium exactly like we treat crude oil or semiconductors, as a matter of national security. The irony of the AI revolution is that our trillion-dollar ambitions are now hostage to a gas that is literally lighter than air. If this shortage continues, the future of AI will require a massive leap in material innovation, because you can't build the future on a foundation that is currently evaporating. If you want to keep following these developments, make sure to subscribe to Tech Brew with Vandana Nair. I'll see you in the next one.